So this is, I'm in section 7.4, and these are proving trig identities. The book says establishing an identity means the same thing. The process is the same. So in 7.4, I like numbers 45 to 76 on this page. So if you need to, you can stop the video and take a photo of this. And on the next page, I like up to probably 90, number 90, 93 or so. You should be able to do them all, but right. So you should be able to do any of those. Let's pick a couple here and then do them now. So I'll start with number 60. So 7.4, number 60. And again, you know, you got the pages there in the video. You can stop it and take a photo of it, or if you had it if you did it live, or if you want me to show it again. And then I will put together a nice little packet of all the problems that you should be able to do in chapter 7 to give you extra practice. So this is number 60. It says sine of theta, cos of theta, all over cos squared theta minus sine squared theta should equal to tan of theta over 1 minus tan squared of theta. So I'm thinking the left-hand side is more complicated. So I've got sine times cos over cos squared minus sine squared, right? I first just write with sines and cosines, so I write a little bit less. And then I don't know much I can do here except for factor downstairs, and I'm looking for that list of anything I could possibly do. So downstairs I get cos plus sine and cos minus sine. How is that with everybody? We okay here? Ryan's the only one I can see today, so I know you're too pissed off at me to talk to me, but you can give me a thumbs up. Everyone's okay. Thank you, Brian, Turia, Oscar, Wilder, Manish, Ben, thank you. Oh, everybody, thank you. Amir, Jamal. So I don't know what else to do here. Thank you, everybody. So I'm gonna start on the other side. I don't know what else to do. I've got a sine over cos for tangent, and then 1 minus sine squared over cos squared. So if I get stuck on one side, I can start on the other, and I'm still just trying to get them to match anywhere, right? So I can see that I can use an interior LCD of c squared, right? You see that? I got one denominator of c, one denominator of c squared, so I can use c squared to clear everything. So now I have sine times cos squared over cos squared minus sine squared over cos squared times cos squared. So I distributed it into all the numerators, right? Is everybody with me? Thank you. So things cancel, which is nice. One of my cosines cancel there, and both my cosines cancel here. So I get sine times cos over cos squared minus sine squared. Oh, I had that already. Done. Match. Finished. Easy. Let's do another one. Maybe 64.
Does it matter if there's a 0 after it, or if there's like a u after it, or a v after it? Does that matter?
No, theta. So any variable is fine. Theta, an x, a v, I usually will just always change things to x's. Theta's used a lot too. So it's just the variable. It's just what you named your kid. You can name your kid anything you want. Right?
Okay.
Yeah. So 64. I have secant of theta minus cos of theta, all divided by secant of theta plus cos of theta equals sine squared theta over 1 plus cos squared theta. Yeah. So clearly the left-hand side is more complicated, right? So I've got a 1 over cosine minus a cosine and a 1 over cosine plus a cosine. I'm working on the left side, right? Secant is 1 over cosine, right? Okay. So it looks like I'm going to clear fractions again with cosine over cosine. And so what do I get? I get 1 minus cos squared over 1 plus cos squared. And you can see I'm pretty much done at this point. Is that okay? The cosines cancel there, and I get a cosine squared there, right? And now I know 1 minus sine squared is cos squared. Sorry, 1 minus cos squared is sine squared, so I'm done. I got sine squared over 1 plus cos squared. Done. That's what I wanted. It's easy and it's fun. Make it fun. You can be that miserable uncle or aunt that's playing Monopoly with all the kids at Thanksgiving and just be miserable, or you could pretend it's fun. And that's what you have to do sometimes to get through family gatherings. Let's look at the next page here. Anything look interesting to anyone? Do 86.
90?
Which one? 90?
90?
Yeah, sure. So I have 1 plus cos theta plus sine theta all over 1 plus cos theta minus sine theta equals secant theta plus tan theta. Well, I don't know what to do on the left. Could be a conjugate. Could be a conjugate. I just don't know what to do. I'm going to start on the right. I get 1 over cos plus sine over cos. I don't know what to do here either. I get 1 plus sine over cos squared. I don't know what to do, so I'm gonna just try something. Brian, do you see something to do on the left?
What if we divide like all through by sine? Is that gonna work? Is that gonna help us?
Oh yeah, that could do it. That could do it. I almost want to divide by cosine instead. Let me try that. So I go 1 plus c plus s over 1 plus c minus s. And I'd like to use a 1 over c on both and see what happens. So I get a 1 over c plus a c over c plus an s over c, all divided by 1 over c plus c over c minus s over c. Just working on, is everybody with me here on the left hand side? So I get a 1 over c plus 1 plus s over c. Well, there's my secant plus tangent. But it doesn't help me really. I don't know what to do. I'm sorry. I'm a failure. It happens. It just happens. I might go back to my right side. I don't know what else to do. On my right side, I can see a conjugate. Who picked this one? Ryan? So here I get 1 minus sine squared over cos squared times 1 minus sine. I'm starting to feel like maybe I wrote the problem down wrong. That's usually what happens when you get nowhere. Let me see what happens again in 90. 1 plus cos plus sine. 1 plus cos minus sine equals secant plus tan. No. Anyway, this gives me now cos squared over cos squared times 1 minus sine. Nope. I'm going to have to work on it and get back to you with it, okay? Can't do it. I'm stuck. It happens. And then you let it go, and it will, something will click. Oh, should have used a I think it's a conjugate. This is 86. Cos of theta plus sine of theta minus sine cubed theta all over sine of theta should equal cotan theta plus cos squared of theta. On the left-hand side, it's kind of obvious that I should divide and conquer. Whenever I have a multi-term numerator, I'm going to use those individual terms over the entire denominator. That might even work on the other one, but I don't know yet. So I get, c over s plus s over s minus sine cubed over sine, s cubed over s. So I get cotangent of theta plus 1 minus sine squared, and 1 minus sine squared is cos squared. Done. So if they don't happen quickly, you started the wrong way. You're trying to walk to California and just start walking to Florida, you'll realize something's wrong pretty quick. So I just may have taken the wrong. Can't think of it. Doesn't matter. So 90, there's our challenge. Ryan, you try it. I'll try it. Let's see who gets it first, okay? Nice. Let's take a look at section 7.3, solving trig equations. So in this one in the book, now this one I do have an assignment on Math Excel. Okay, so make sure you do those. But then I also want to just look at a few right here. So 7.3. Just looking for that nice grouping of questions that I'd like you to be able to do. All right, here they are. So I definitely like 59 to 82. If you can take a quick photo of that, 59 to 82. And I think some on the previous page are good to do as well. Yeah, 37 to 58 are good to do as well. So I'll just pick a couple of these. The ones where you have to use a calculator, don't do. We want the ones that you don't need a calculator, and we want a general formula for things. So I'm going to do probably 44. I'll do that one next. I'm going to look at the next page here. Let's see if I do. Let's try 71. See what that looks like. So 71 and maybe 60, 67. Let's see what happens. So this is 7.3, number 71. I've got the tan of theta equals 2 sine theta. So I really want to be thinking of this just like a trig identity. That's why we do these trig identities. I've got a sine over cos minus 2 sine equals 0. And the key here is that I can factor. When you have more than one trig, you're usually trying to factor, unless you see the quadratic formula right away, right? So this is sine times what? 1 over c minus 2 equals 0, right? So I either get sine of theta equals 0, or 1 over cos minus 2 equals 0, right? And that, of course, is what? Cos equals 1/2. Right? Cos of theta equals 1/2. You agree with that? So I've got two equations here. The first one I can solve very quickly just by thinking of my mother function for sine. I can see that it hits at 0 at 0 pi, at pi, at 2 pi, so every k pi. So theta equals k pi. And cos equal 1/2 as a reference angle of what?
Is it 3?
Pi over 3, yeah. So I know I'm building out that table or my pizza, right, with 6 slices in the pizza. Pi into 3, the whole thing into 6. I know the positives are over here on the right, right? So I get pi over 3, 2, 3, 4, 5 pi over 3 are my solutions. So I get theta equals pi over 3 plus 2k pi, right? I can go all the way around the circle to get another answer. And then theta equals 5 pi over 3 plus 2k pi. And on this one, it doesn't turn out to be a nice general answer. I had done one like that last time. I'll make sure I do one that does come up with a general answer next class or Monday or whatever. So there are my answers. I think I said 67. Is everybody okay here? So I've got sine squared theta equals 6. No, I don't want. Really? 6 cos theta? Oh, yeah. 6 cos of negative theta plus 1. So they want me to distribute and use a even odd identity here. So I get sine squared equals 6 cos of theta, right? Cos is even. Cos is even, so cos of theta is the same as cos of negative theta. So I'm sorry, sine squared equals 6c plus 6. And this looks like a quadratic to me if I change my sine squared into 1 minus cos squared. I'm going to make it into a quadratic, moving everything to one side, right? So I get c squared plus 6c plus 7. What? No, plus 5. Plus 5, thank you. So there's my quadratic, right? So I get c is equal to negative 6 plus or minus the square root of 36 minus 20 all over 2. I just did my quadratic formula really quickly there. Is that okay with everybody? Nice. So c equals negative 6 plus or minus square root of 16. That's nice, all over 2. That's negative 6 plus or minus 4 all over 2. So c equals negative 10 over 2 or negative 2 over 2. Okay, well this one can't happen, right? Cosine can't equal negative 5. Never equals negative 5. In fact, the lowest it goes is negative 1, right? So there's no solution from this. And this one says cosine of theta is equal to negative 1. Well, that's nice because I know when that happens, right? Cosine hits a negative 1 every pi. So every odd pi. So 1 pi, 3 pi, 5 pi, 7 pi. So theta equals 2k plus 2k minus 1 pi. We knew that odd sequence from chapter 12. 2k minus 1, 2k plus 1, either one. Nice, one more. Number 44. How we doing? We okay? Thank you, Cindy. So sine 2 theta is equal to minus 1. Now, my trick on this is not when the interior function is complicated, make it simple. So let x equal to theta. So now I'm solving for sine of x is negative 1. And that's very easy. I know when sine is negative 1, right? Sine is negative 1 at every, so x equals 3 pi over 2 plus 2k pi, right? So the first time sine equals negative 1, it's 3 pi over 2. And then I know I go around the circle again, so I add 2 pi once, I get another answer. Add 2 pi twice, I get another answer. Add 2 pi 3 times, I get another answer. So there's my 2k pi. I'm not going to factor this. It looks like I can factor it, but I'm not going to factor it yet because I got to remember that x is 2 theta, right? So 2 theta equals 3 pi over 2 plus 2k pi. And now I'm going to, remember, I'm solving for theta, so I'm going to divide everything by 2. I get theta equals 3 pi over 4 plus k pi. And now it looks like I could factor it, but it doesn't do that much for me. It doesn't do that much for me to factor out this pi here. So I think I would leave it alone. Maybe I would factor out a pi over 4. That might be more interesting. So what do I get? I get a 3 plus 4k. I think that's a prettier answer, but this one's probably the one in the book. Nice. So there's 7.3. So I gave you problems to do in 7.3, and there's MathXL homework in 7.3. Then there's problems to do in 7.4. Those just come right from the textbook because it doesn't make sense for MathXL to try and grade you on those. It doesn't, because you can do 20 steps and get there, or you could do 3 steps and get there. So MathXL has a hard time asking those questions. But anyway, we're ready to start 7.1, inverse trigs. So we deal with really only the inverse trig for sine, for cosine, and tangent. The others we don't really talk about at all. And you'll see most of the time when I'm working with an inverse trig, I'm trying to work with a trig instead. So if I see an inverse trig, I'm actually thinking about the trig function, right? So we'll start with our sine function. And our sine function, right, we know the mother, right? But the issue, of course, is what? What's the problem with this function in order to get an inverse? It's not one-to-one. So what we do is we restrict our domain. We're going to restrict the piece of the sine function from here to here. So our restricted sine function, and we're trying to stay as close to the origin as we can every time. So now our f of x equals sine of x on minus pi over 2 to pi over 2 is 1-to-1, right? With a range of minus 1 to 1. And now f inverse of x, which is sine inverse of x, or the arcsine of x, is the inverse function. I tend to use the arcsine notation just because a lot of students confuse that reciprocal looking notation, which by the way is not a reciprocal, it means inverse, right? So I tend to use the arcsine most of the time when I'm doing problems. Now I want to notice where my restricted sign is and which quadrants my restricted sign is happening, right? And so you could see that it is in quadrant 1 and 4, right? My restrictions are in quadrant 1 and 4. So I really want to be thinking about my bow ties to happen either in quadrant 1 or quadrant 4. I want my triangles, I want to be thinking only about quadrant 1 or quadrant 4 when I'm dealing with arcsine. Everybody with me here? So pretty much this picture is going to go on to my formula sheet for the sine function, for the cosine function, and for the tangent function, right? So that whenever I start to deal with an inverse trig, I can use this stuff to make sure I'm understanding everything. So a typical answer would be something like, what is the arcsine of minus 1/2? Right? So that's the question. So I don't think in inverse trigs. Go ahead, Manish. I don't think in inverse trigs. I think in trigs. But I know what the answer to an inverse trig is. What is the answer to an inverse trig equation? What's the variable I can use for my answer here?
Oh,
Say it again.
oh,
So it's not a function. I want a variable,
X.
not x. It could be x, but I want a different one because where I'm going. I want theta.
Y.
I want theta.
Theta.
So if you think about it, the input of a trig function is an angle. The output of an inverse trig function is an angle, right? So I don't think in terms of inverse trigs. I think in terms of trigs. So I want to take a composition of sine of both sides, right? On the left-hand side, I had arc sine of minus 1/2. And on the right-hand side, I have a theta, right? So what happens on the left side? What happens to sine and arc sine? What's their relationship?
Inverse.
They're inverse, so they cancel each other. So now I get to think in terms of trigs. I don't think in terms of inverse trigs. I think in terms of trigs. Because now I'm back in chapter 6 and it's easy. What's my reference angle? You're killing me.
Pi over 6.
Thank you, pi over 6. So I'm cutting pi into 6, which means the whole thing into 12. And I know I've got to be in either quadrant 1 or quadrant 4 from my inverse trig knowledge. So I know I have to be in quadrant 4 because that's where I'm going to get the negative 1/2. Sine is a y value, so it's going down. So my answer is now what? Good, minus pi over 6. You might think I can go to 1, 2, 3, 4, 5, 6, 7, 8, right? You might think I can go to 11 pi over 6, but 11 pi over 6 is happening over here, and I have to be in quadrant 1 or 4. So I cannot be in quadrant 4 all the way to the right. I've restricted my domain. How are we doing? One more time. I lost a student. Let me take attendance again. Let's look at the cosine function. So y equals cos of x, and f inverse of x equals arc cos of x. So when I'm looking at the cosine function, right, I get this nice little piece, which is 1-to-1 right away. If I used the left part of that cosine function, I would have something that was not 1-to-1. So if f of x is cos of x on 0 to pi, right, then f inverse of x is arc cos of x, right, on minus 1 to 1. Cindy asks, why not 5 pi? So on the last one, why not 5 pi over 6, right? Because 5 pi over 6 is positive. 1, 2, 3, 4, 5. And I need sign to be negative. And 5 pi over 6 is in quadrant 2. I need sign to be in quadrant 4 or 1 in order to get the 1 to 1 piece. Thank you. Good. So for cosine, I'm in quadrant 1 and 2. So my rectangles in that case are going to be either here or here, right? I'm going to be either in quadrant 1 or quadrant 2. Right? Quadrant 2 if it's negative. Quadrant 1 if it's positive, right? So let's say I want the arc cos of the cosine, sorry, I just want the arc cos of minus rad 3 over 2, right? And I don't know what that answer is, but I know that the inverse trigs are going to give me an angle, theta. But I don't want to teach, I don't want to think, I don't want to teach in terms of an inverse trig. I want to teach in terms of a trig. So I'm going to take the cosine of both sides, and I end up getting cos of theta is minus rad 3 over 2. And then I'm thinking, what's my reference angle? Killing me today. 3, 6, 9, 12. Pi over 6. So pi over 6. So I'm going to cut pi into 6 or the whole thing into 12. Look at my bow ties, but then realize the bow tie I want is in quadrant 2, right? Because that's when cosine is negative. So I'm going 1 pi over 6, 2, 3, 4, 5 pi over 6 is my answer. So the arc cosine of minus rad 3 over 2 is 5 pi over 6. How we doing? Nice. We got one more inverse trig to talk about it, but it's the same as sine. It's tangent, right? If I look at tangent from minus pi over 2 to pi over 2, it's already 1 to 1 on that one piece, right? So this is f of x equals tan of x on minus pi over 2 to pi over 2 with, again, our quadrant 1 or 4 for our bow ties. And then f inverse of x is the arctan of x on minus infinity to infinity, right? Notice I'm grabbing the domain of the inverse from the range of the original, right? So I want to be thinking about those two things, right? Well, let's see what happens. We get sine of the arctan of 1. So let's see if we can solve this. Sine of the arctan of 1. When is tangent equal to 1? Can you see the reference angle?
That's pi over 4?
Pi over 4, yeah, exactly. So this simply becomes the sine of pi over 4, right? And we know we're in quadrant 1, so I get what? Rad 2 over 2. So lots of things to read. Please read section, read the section, and then do the homework. Let's try a couple of tricky problems and then we'll quit. So let me open the book for section 7.1. So a bunch of problems here. I definitely think the use of the calculator ones are not that interesting. So I like 15 to 26 here. I certainly like 39 to 54. Let's do 52. So inverse sine of the sine of negative 3 pi over 4. Now you see a function and its inverse, and you're saying to yourself, well, does it cancel right away? I forget what number this was again. Sorry. What did I say? I forgot which one I said. Oh, it's 52, right? Yep. So I want to find the value of the inverse sine of the sine of minus 3 pi over 4. And I would say your gut instinct is just to say that the inverse sine and the sine cancel, right? But the answer is not minus 3 pi over 4. The answer is not minus 3 pi over 4. Because inverse sine can't exist there, right? I've got to be thinking about my quadrants. Where is 3 pi over 4? Well, negative 3 pi over 4, right? It's here, right? So, but since I'm dealing with a sine function, all I have to figure out is which angle will give me the same height for sine. And it's obviously minus pi over 4. So inverse sine of the sine of minus 3 pi over 4 will have the same result of the inverse sine of the sine of minus pi over 4. Right? Now my functions cancel each other because I'm inside of the right quadrant. So I get a minus pi over 4. I can do this problem another way, and that is using my drunk Aunt Sally, right? I can just start on the inside here. So inverse sine of the sine of minus 3 pi over 4. Well, I know the sine of minus 3 pi over 4 is what ratio? Good, minus rad 2 over 2. And I know the reference angle for that, right, is pi over 4. But it has to be in quadrant 4. Remember, inverse sine works in quadrant 1 or quadrant 4, right? So again, I'm saying this is theta, right? So sine of theta is minus rad 2 over 2. So there's my pi over 4. But I know I have to be in quadrant 4. So I get theta equals minus pi over 4. Same answer. So I have to be careful about, am I in the domain and range of the trig so that I'm 1-to-1, right? So that I can use the inverse trig. That one's weird, I know, at first. Let's look at another one. I'll just make one up here. So this is just kind of out of my head, but it's a real important one for you for calc. And there's a bunch of them in section 7.1 and 7.2. So, but what if I just said I want the cosine of the arctan of x? So I want us to simplify this. Well, what do you see here? What's the main thing you see? Is there a way to write this problem easier? What can I really say? Cosine of what? Oh man, what's going on? Are you all what? You lost? Or are you just giving up? What is it? You just hate me that much today? What is it, Ryan?
I was gonna say we're gonna put on sine on cos.
Yeah, what am I replacing the arctan x with? This is here. What could I put in there that's a lot easier? Anybody?
Arc sine over cosine.
Simpler.
X.
Not x.
Theta.
Yep. Whenever I see an inverse trig, I want to think theta. So now you can really see that theta is arctan of x, right? But I don't think in inverse trigs. How do I want to think? In terms of trigs. So what should I do to both sides? How should I compose both sides? I'm going to take the tangent of the left side and the tangent of the right side. What happens on the right side? Anything go away? Anything cancel on the right side? Oh my God.
The tan.
Yes, the tan and the arctan, they're inverse. They cancel each other. So notice what I have now. Tan of theta is x. When I have a trig, I now have a triangle. This is important to remember. If I have an inverse trig, I have a theta. If I have a theta, I have a trig. If I have a trig, I have a triangle. So my triangles in these situations all live in quadrant 1. And tangent equal x is tangent equal x over 1. So the height is x, the base is 1, and I can figure out the other side by the Pythagorean theorem, square root of 1 plus x squared. Now I'm ready to answer the question. Cos of the arctan of x is simply cos of theta from the triangle, which is what? 1 over the square root of 1 plus x squared, right? Adjacent over hypotenuse.